there are three laws. We say the law of motion, which is found by Newton's. We said the Newton's three laws of motion. Newton's first law, second law, and three laws of motion. Now, what are these laws of motion? What does it say? You see, back then in the early ages, people, they asked very basic questions. What I mean by basic questions, very fundamental questions. Questions that we don't even ask or we don't even bother asking. For example, question like, why should an object move? Or why should an object stop? These are the very fundamental, very basic questions that sometimes is very difficult to answer because object move is just moving. That's just how it is, right? But we never ask why should it move in the first place. So the Newton's law of motion answers all the questions to these fundamental questions. So again, it answers the fundamental questions. So they are called the fundamental law, a very basic law. Okay. Where does it come from? Over the years, there are a lot of observation, research. Okay, people, they do research, they do calculation, they do observation. And then all of this, they compile together. They compile together, they stack it, they put it into one book, and then they publish the book that they call it the Newton Three Laws of Motion. So today we will look at the three laws, all the three laws. Here, we are looking at the first law. Again, it is a very basic law. Now, what does the first law say? The first law says that it is the law of inertia. Now, what is mean by inertia? Inertia, put it simply, it means no motion. Inert. Okay, the word inert means no motion. That means if an object is not moving, then it will stay at rest. That means if we have an object that is at rest initially, then without any force acting on it, it will stay like that. It will stay at rest. So object at rest will remain at rest, and object that is moving, it will remain moving unless there are external forces apply on it. Okay. At first, it may sound a little bit confusing. Now, let me explain. Every single object that you see around you, every single object, they have characteristics. What is that characteristics? They have these characteristics that they cannot do anything by themselves. All right? They cannot do anything by themselves. For example, let's say we have an object here on my hand. What is the state of motion of this object? When I say state of motion, there are three states of motion. We have stationary, which is at rest. We have constant speed, so moving at constant speed. And then we have accelerated motion, whether accelerating or decelerating. So three types of motion. When I say the state of motion, there are the three. So an object that is initially at rest on my hand, what is the state of motion? This is stationary. Okay. Now, by itself, if the object wants to move by itself, it cannot do that. How do I move the object? There must be something from the outside world that is applying the force to cause the object to move. There must be something from the outside world apply a force to change the state of motion from rest to moving. So I pick it up like this. I'm applying a force. Now it is at motion. Now it is in motion. Before it was at rest, I do it like this. Then it is in motion. So I'm changing the state of motion by applying a force. So I can say that my force changed the state of motion. Again, my force changed the state of motion. So there must be a force to change motion, to change one state to another one. Okay, without the force, it will remain at rest like this. Another example, an object that is moving, it will continue to move until someone apply the force to stop it. What is the force? That is the friction. Friction with the air, friction with the ground. Let's say a ball rolling. There are friction with the air, with the ground, and then eventually the ball will come to rest. Without the friction, what happened to the ball? It will continue to move. It will not stop. It will move forever until there is a force applying on it. Like a ball moving in space when there's no air. When it is moving, it will continue to move until it hits something. It never stops because it's in outer space, there's no friction, right? Okay, but in our surrounding, there's friction, so there's external force. Friction is also external force. Okay, somebody from the outside, external stuff. Okay, because the force coming from outside, right? So we call it external force. So I step in, the ball is rolling, and then I step in, I pushed it. So my force is from the external. Okay, so it's like something come in and disturb. So what is inertia? Inertia, it is a property of an object. What is a property? When I say a characteristics, like for example, your characteristic, okay, you wear spec, you are long hair, or something, you are tall, that is your characteristics. So inertia is also a characteristics of an object. Okay, we say that it is an inherent characteristics here. Inherent, what does it mean by inherent? This one is like naturally occurring. Okay, it is already there. Something that it is born with, inherent. Okay, so inherent characteristics of an object due to which it continues its condition of motion. What is the condition of motion? You have rest, you have constant speed, and then you have accelerated motion. Okay, so there are many examples of inertia. Now, when the question asks you, state Newton's first law of motion, or state the law of inertia, how do you answer? Okay, this one, copy paste down here. This one, here's how you describe it. An object at rest will remain at rest, and an object in motion will remain in motion unless what happened? Unless an external force is applied on it. Okay, so every single object, they cannot do anything by themselves. They need something to change their state of motion. That is the meaning of inertia. Now, we will look at one very famous example, which is the moving bus. A bus traveling, we have seen that a bus traveling, we separate into two situations: when the bus starts moving and when the bus stops moving. What happens when the bus starts moving? You lean backwards, right? You lean backwards. And then when the brakes are applied, you bend forward. So if we break it down into two situations, let's see how we can explain this, right? This is something that we see every day. But how can we explain this using the concept of inertia? Now, I separate into two sections. Let's see the first situation, bus start. Okay, bus start moving. Now, here is the seat. And this is the passenger, like that. The lower body of the passenger is attached to the seat, but the upper body is not attached to anything. And then the seat is attached to the floor, and the floor attached to the body of the bus, and it attached to the engine. Okay, now when the driver pressed the accelerator, immediately a force from the engine is produced. So because the body of the bus is attached to the seat, everything is attached. So when the engine apply the force, all the force apply on every single body as well. So that means this lower portion of the body, force acting on them. Okay, because they are attached as one. Now, force acts on them. As soon as the force acts on them, what happened? Their state of motion changes. Okay, so there's a force, it changes the state of motion. So that means the lower body of the person start moving. But what happened to the upper body? The upper portion of his body, because the upper portion of his body is not attached to anything, right? So it is initially at rest. Now it wants to remain at rest also. Here, the lower body started moving, but the upper body want to remain at rest. Why does it want to remain at rest? Because of, again, because of its characteristics, inertia. Because the inertia of your body, it wants to remain at rest. So that means the lower portion has come here. Everything has moved here, but your upper body remain at rest. That means it remained at that same position. That's why you lean backwards. Okay, so what do? You do like this. Here, you do like this. Okay, you lean backwards. Why should you lean backward? Because your upper body has an inertia of rest. Lower body, all this has come here, has come forward. Okay, but then eventually your upper body catches up. Okay, catches up because your upper body is connected to your lower body, so it cannot be left there, right? Eventually it catches up. So eventually the force is also applied on your upper body. So this only happened momentarily. Okay, now let's see second situation when the bus stops. Okay, now you are moving here. You are moving with a certain velocity, v. Your position has come back to straight posture, and then now you are moving at certain velocity. Suddenly, the driver pressed the brake. Again, when he pressed the brake, friction is produced on the wheel. Friction causes the wheel to slow down, and the floor, the seat, they are all attached. So the same force acts on the lower portion here. There's a force opposing motion. So it is going to the right. This is friction going opposite to it. It starts to slow down. Okay, what happened to the upper body? The upper body wants to continue whatever it is doing. Initially, what is it doing? Please look at before and after. Before, what is the upper body doing? Moving. After, what it wants to do? It wants to continue moving. So what happened is that you lean backward. You lean forward like that. Okay, you lean forward. What happened to the lower body? Lower body has already stopped, but upper body has not stopped yet. It is still continuing because the force has not acted on it, because the upper body is detached from all of this. So this is the example that you see inertia in action. You see it in your everyday life. Okay, so this is how we explain it, why it happens. Because of nature. Okay, why? How do we understand it at the very basic level? Because according to nature, every single object has a characteristic. What is that characteristic called? That characteristic is the inertia. Okay, yeah? Understand? Now, I'll give you another example. There's a car moving in this direction, like that. There's the car moving here, facing this direction, and then suddenly the car make a very sharp turn like that. Okay, turn here. There is a person sitting at the back of the car. And then suddenly, when we make a sharp turn, by any chance, if the person has not closed the door, we come here, this person go here. Okay, we come here at first, initially, we are moving in this direction. And then suddenly we make a turn, this person continue to move in this direction. But now we are turning. What happened? If it happens that the door has not closed, then the person is thrown out on the road here. Why does it happen? Because initially everybody is having inertia in this direction. Okay. And then when I turn the steering wheel, I apply a friction on the gear, on the working of the engine, on the wheels, there is a friction. And then this friction also applied on the road. So there is a friction between the road and the wheel that causes the car to turn. Okay, we have successfully turned the car, but the person at the back, unfortunately, he has not held onto the things around him. So that means all this friction is not acted on his body. Okay, he has not held the seat. So the friction does not apply on his body. So what happened is that we have changed our motion in this direction. This person continue his direction here. So he goes here. We have come here. What is this inertia? This is we call inertia of direction. Okay, inertia of direction. The bar start. This is inertia of rest. Inertia of rest. Look at the initial state of motion. Initially, it is at rest. So I will say it is the inertia of rest. This one, initially, it is moving. So we say that it is the inertia of motion. And in the case of the car, this is having inertia in this direction. We have turned here. This is inertia of direction. So you have three types: inertia of rest, motion, and direction. Okay. How do you clean the rug or a blanket, anything? How do you clean it? You hold it up like this, and then you take a stick, you hit it, right? You hit it, and then all the dust fall off. Okay, you hit it, and all the dust fall off. So, how do you explain it with inertia? That is also inertia. You see, you hold the blanket like this, all the dust particle is sticking to it. Everything is at rest at first. What is the initial state of motion? Rest. Now, I take a stick and then I hit it. Because all the dust particle is not firmly held on the blanket. All the particles are just loosely settled on the cord of the blanket. It is not firmly attached to it, right? So when I hit the blanket, the force acts on the blanket. The force cannot act on the dust particle. The force that you apply acts on the blanket. So what happens is that that force causes the blanket to move backward. What happened to the dust? The dust still stay at the same position. The blanket already moved here. This is the blanket. This is the dust. When you hit it, the blanket moves here. But the dust stays at this position. Then fall off. All the dust came off. Again, it is due to the inertia of the dust. The dust want to remain at rest because the force that you apply has not acted on the dust particle. So they remain at rest, but the blanket has moved. Then that is also inertia. Okay, so that is also one example. So you see inertia in your everyday life. Okay, that is a short one. That is what Newton's first law is saying. What is Newton's first law again? Law of inertia. Okay, and things that you need to remember. This you need to remember the sentence. Yeah, you want to take this down, and this one, because when you are asked to state the law, you need to give in full statement. Yep, you need to give in full statement. So you kind of want to memorize. I wouldn't say 100% memorize, but at least you want to get as close as possible without changing the meaning. Okay. Okay, 1 minute, and I will go to the next slide. Okay, next one. We continue. Now we look at Newton's second law. Okay, Newton's second law of motion talks about forces. Now, a very short answer for Newton's second law of motion is that you just remember this F equals to ma. Okay, F equals to ma. What is m? M is mass. A, acceleration in SI unit. That means force is Newton, m is kg, acceleration is ms minus 2. Okay, now what does it say? Force is directly proportional to the rate of change of momentum. Okay, when you read this question, when you read this sentence, okay, it's very confusing. Now, let me break it down. Let me explain. You see, let's start from momentum. What is momentum? You have learned this, right? Momentum. Short answer, mass in motion. Anything that has mass and anything that is moving has mass and it is moving. It has a momentum. Okay, so let's say there is a cyclist coming towards me. Okay, there is a cyclist coming, and then I go approach the cyclist, and then I hold the cyclist. I try to stop it. Am I able to stop the cyclist? Yes, maybe, but maybe it takes a few steps backwards to stop the cyclist. But I'm able to stop it, right? I apply a force, I stop it. Now, let's say there is a truck coming. I go on the road and I try to stop the truck. Am I able to stop the truck? Okay, that is pretty shocking. The truck will continue come here. When I try to stop it, the truck will hit me and then continue moving without stopping. Compare this to the first situation, the cyclist, I'm able to stop it, but the truck, I cannot stop it. Why? We say that the truck is having greater momentum. The truck is having a very large momentum. Something that has very large momentum, it is difficult to be stopped. Let me write it down here. Something has high momentum, it is difficult to be stopped. And the same for if you want to start moving it. So I will write here difficult to be stopped or difficult to be started. Okay, if you want to set something in motion, for example, there is a car and a truck stopped at a traffic light. When it's red light, they both are stationary. Now, when the light turned green, both driver, they step on the accelerator, they apply the same force. Both started moving, but you will see that the car is ahead of the truck. Okay, it takes longer time for the truck to accelerate, to set in motion. It takes longer time to move the truck, provided the same force is applying on the two vehicles. So again, the truck is more difficult to be started. Okay, it's more difficult to start in motion. So again, we say the truck has higher momentum. What is the main factor that causes object to have high momentum? Number one, mass. Okay, something that has high mass, it has high momentum. Okay, like the truck and the cyclist. The cyclist, very small mass, truck, very high mass. Other than the mass, what else? There is a bullet traveling in this direction. Let's say I'm bulletproof, and then I put my hand here. The bullet go like this and hit my hand. How fast is the bullet? Very fast, 500 meters per second, let's say. It's traveling very fast. Is it heavy? Not really, right? A bullet is it's not that heavy. Okay, depend on the gun or on the what size of the bullet. Let's just say that the small bullet, it's not very heavy. Okay, maybe 20 grams, but it is traveling very fast. I put my hand here. I try to stop the bullet. Can I stop the bullet? Okay, maybe yes, maybe no. But when I put my hand here, it's going to push my hand backward for some distance. Okay, again, it is difficult to stop because it is moving at very high speed. So, does it has high mass? The mass is not high, but the speed is very high. Again, it is difficult to stop, so the momentum is very high. So the second factor that affects momentum is velocity. A fast-moving bullet is very difficult to stop. So it has high momentum because of the velocity. So these two needs to be there when you're talking about momentum, okay? So if these two needs to be there, then your equation is going to be P. What is your equation? P equals to mv, mass times velocity. What is P? P is the symbol for momentum. Okay, so now m is in kg, v is in meter per second. So this one, you multiply into it, what do you get? Kg meter per second. That is your unit of the momentum. Momentum is a vector quantity. It has a direction. Why is it a vector? Because in the formula, there's a velocity. Velocity is a vector, so momentum must be a vector. If I say that an object 2 kg is moving at a velocity of 5 to the right, what is the momentum? P equals to mv equals to 5 times 2, 10 kg meter per second to the right. If the ball bounced back and now it is moving at a velocity of 2, what is the momentum right now? Okay, P equals to mv equals to 2 times this one. It is now moving in opposite direction. So opposite direction, we use a minus, so we put minus 2 here. Okay, so minus 2 equals to minus 4 kg ms minus 1. This is having momentum to the right. Once it bounced off of the wall, now it is having a momentum to the left. Okay, so initially it has momentum in this direction, and then after that it has momentum in this direction. So momentum is a vector quantity. That means it can have positive and negative sign because of the V. So you need to be careful with that one. Okay. So how do you define momentum? Put it simply, we just talk about it is a product of mass and velocity. That's it. 如果 question 问你 what is momentum? 你直接跟他讲 okay, product of mass and velocity. That's it. Okay. So that is the technical definition of the momentum. Product means multiply, right? Multiply. So because the formula is m times v. So product of mass and v. Okay, now you know what is momentum. Mass in motion. Anything has mass and it's moving, it has momentum. What is another meaning of momentum? Like when you wake up in the morning, or okay, let's say you want to do a task. You want to do a task and you keep postponing the task. What happens whenever you want to, you feel like you want to do a task and then you keep postponing it, right? Because it is very difficult to start doing it, right? Especially like when you are talking about a heavy task or a bigger task. So what happens is that they say, okay, if you have a very big task, you separate it into small tasks and then you do it bit by bit. Okay, it's like you separate it into smaller tasks so that you You tackle the first small task first, just to pick up the momentum, right? You do the first task, and then now you are on the go. You are going right now. It's like you have the momentum, and then you can do the second task. You do the third task. You do the fourth task, and then eventually you finish the task. Okay, but if you straight away do the big task, then you find it very difficult to start because you don't know where to start. Okay, so you keep procrastinating. Okay, so that is another different meaning of momentum. Okay, so when you have the momentum, you keep going, right? It is because when you have the momentum, it's very difficult to stop, so you keep going. So that is on the different meaning. Okay, that is not based on physics lah. That's the different meaning of momentum. Now, when you wake up in the morning, okay, you don't feel motivated, or sometimes when you wake up, maybe you feel motivated, and then the rest of the day you can do a lot of stuff. So you have this momentum going on. You have this momentum going on, then you keep on doing the task throughout the day. Okay, that is also momentum. All right, now you get a point. Now, Newton's second law of motion talks about what? Okay, first, what we know from previous lesson, the previous slide, we know that force can do what? Can change the state of motion. The state of motion. The same force can also change the momentum of an object. Object initially at rest. Now I pick it up. A force is applied. I raised it. What is the initial momentum? 0, because there's no velocity. Now it is moving, so it has certain momentum. So we say that there is a momentum change from 0 to some certain values. What causes this momentum to change? A force is applied. So I raised it like that. So I say a force can change the momentum of an object. You cannot change the mass, right? If I have an object here of mass m, you cannot really change the mass. The mass stays the same. But what you can change is the velocity. At first, the velocity is 0, and then you apply a force. Now the velocity is, 5. Mass is still the same. So if you calculate the momentum, it has changed. Here, momentum P1 is 0. Here, momentum P2, mv. Who changes the momentum? Force changes the momentum. This force that you apply. Okay? Now, so this is change in momentum. When I calculate 2 kg, what is the momentum before? Momentum before 0. What is the momentum after? 2 kg times 5, 10 kg, ms minus 1. From 0 to 10, there is a change. The force causes the change. The change in momentum, we give it a name. We call it impulse. I can write impulse as change in momentum. That means it is the 10, right? ms minus 1. From 0 to 10, what is the change? 10. So impulse is 10. If I want to get the formula of impulse, change in momentum, I will write it as mv minus mu. V, final velocity. U is initial velocity. So this is final momentum, and this is initial momentum. Impulse symbol is I. Okay, so here I get a formula. I equals to mv minus mu. Please remember this formula. What is this formula? This is the formula for impulse, which is also called change in momentum. Okay, calculate the change in momentum. You take final minus initial. You get the change in momentum. It is also called impulse. It's the same thing. Okay, what causes the change in momentum? The force causes the change in momentum. So whenever there is a change in momentum, you know that a force must be there. Right? Now, let's come back to second law of motion. Now we read the sentence again. Force is directly proportional to the rate of change of momentum. Let's do a little bit of mathematics here. You see, I erase the space on top here. From our formula, F equal ma, acceleration formula is what? Final V minus U over T. Okay, put it in. M bracket V minus U over T equals, okay, the M times into this one. M is M over 1. So numerator times numerator, we got M V minus U over T. Expand the bracket. So I times the M inside here. MV minus MU over T. F equals this one. You see the numerator, the one on top, MV minus MU. What is that? This is my impulse, right? MV minus MU. That is the change in momentum. And then you can see it is divided by time. Anything that is divided by time, we would call it rate. So momentum divided by time. Again, change in momentum, right? Divided by time. So that becomes rate of change of momentum. So on your left-hand side is force is equal to change in momentum divided by time. So force is equal to rate of change of momentum. That's where you get this sentence here. Force is directly proportional to the rate of change of momentum. So this sentence here is talking about MV minus MU over T. Directly proportional means when this increases, that one increases. Okay, the graph is like a straight line. You learned about this one, right? Directly proportional. The graph is a straight line. So when force increase, that increase. Okay, the way we think about it is like that. When the rate of change of momentum increases, the force acting on an object increase. Okay. For example, when object hit another object, this object is having momentum 100 in this direction. Once it hit the wall, suddenly the speed decreased to 0. Because when it hit, it has to stop, right? So initially 100, hit becomes 0. So there is a change in momentum. How fast is the change in momentum happen? That is calculated by the time of the impact. What is the time of impact? Okay, so you have a change in momentum and then you have the time of impact. That is going to tell you how much force is acting on the object when it hits something. I repeat, from the equation, so I'm explaining this equation. What is the meaning behind this equation? Force is the change in momentum divided by time. So we have an object coming, having a momentum of, let's say, 100. It strikes the wall, and then the momentum goes down to 0. So the change in momentum is 100, correct? From 100 decrease to 0. So 100. The time of impact, what is the time that it hit? The time happened very fast, not even 1 second. Okay, it comes here, it strikes, not even 1 second, maybe, okay, 0.5 seconds. 0.5 seconds. So we take 100 divided by 0.5 seconds, the time of the impact. What do we get? 100 divided by 0.5. Our force is 200. So you see here on the left-hand side, we get 200 Newton. What does it mean? That means the 200 Newton is acting on our object when it hit. Okay? That is the force of impact. The force of impact. Is it negative? Is it negative value because MV is 0? Yes, correct. Yes, very good. It is negative value. Negative value, that means what? That means the force is acting on the object. Let me draw it. If I draw it out, then you can see what I'm saying here. Let me erase this first. So you have two bodies. One is the wall. This is the wall. And then you have the ball. Negative, you get a negative value is because the force is acting on the ball and is pointing to the left like that. F. So this force is facing to the left, so it is a negative. That's why you get a negative. Okay. Now in the actual cases, there are actually one more force acting on the wall like this. It makes a couple. Okay, this one will come to it later, which is the Newton's third law. Okay, the Newton's third law, basically it says when you apply a force on something, there is a equal force in the opposite direction. When you hit something, you apply the force, and then the wall apply the same force back on you. So you have two forces. One is acting on the wall, one is acting on the ball. So you get negative is because you are getting this force here, which is facing to the left. Okay, so I write it here. This is force on ball. What about this one? This is force on wall. This is, we call action reaction. Okay, it's like when you punch the wall, you feel pain also, right? You punch the wall, you feel pain also. So the force acts on the wall because you punched it. The wall also acts the force back on your fist, and you feel the pain. Two-way. It's always like that. It's always coupled. Okay. Now, any question? Any other question from the other students? If no question, then I'll just continue. All right, now, how many formula you have so far? You have this one, mv minus mu over t. This formula, usually we use it for the impact, because you got the time, right? The time of impact. This force, we call it impact force, or we say impulsive force. Impulsive force. And then other than this one, we got this one. The one that I boxed is the one that you need to remember, okay? This is impulse. And of course, the general formula of momentum P equals to mv. Okay, there's one more. I write it down here. If you take the F equals to mv minus mu over t, you bring the t over there, you get ft equals to mv minus mu, right? So, and also you know I is mv minus mu. So that means, already here, I equals to mv minus mu. That means these two are equal. Okay, these two are equal. Ft and I, they are equal. So I is also equal to force times time. You have the last formula here. Impulse can be calculated by using the force times the time of where the force acts. Later, I will give you exercises on this one, how to calculate using the formulas. Okay, so how many formula total? We have this one, this one, this one, and this one, 4. If they give you the velocity, then you use this to calculate the impulse. If you don't have the velocity, you have the force time, then you would use this to calculate your impulse. Right, 1 to 2 minutes. Take down whatever that you need to take down, and then we'll go to the next slide. Okay. Just a second. Right. Okay, recap a little bit. Short one. First law, inertia. Second law, F equals to ma. Okay, this one I can write it as F equals to mv minus mu divided by t. We have shown the how you get this, right? Okay. The way you explain second law, you would use the second one. That is more accurate, which is you would say F is directly proportional to the rate of change of momentum. Okay, the F equals to ma is for calculation, but the law itself says this one. So when you're asked what is the second law, you cannot just say F equals to ma, because that is not what the law says. The law is saying what? The law is saying this one, directly proportional to the rate of this one. The F equals to ma is for the calculation only. Okay, but the way you remember it is this one, because it helps you remember easier. All right. Now, this formula, we have so far understood the impulsive force is an impact force, correct? Sometimes they also call it the average force. In case you see it somewhere, calculate the average force when this one hit the other one. That is the impulsive force, okay? Impact force equals to mv minus mu over t is the time of impact. And mv minus mu, you already know. Okay, the impact force, the equation shows that very clearly. The impact force depends on what? Depends on one major factor is the time. When the time increase, what happened to the force? The force comes down. When the time decreases, the force will be very large, because they are inversely proportional, right? So that means if the time of the collision is very short, millisecond or microsecond, then the force produced will be very large. Based on this concept, how do we minimize the force of collision when something collides with another one? That is also impact. Okay, so the application of this formula allow us to study. If I want to decrease the force of impact, what should I do? If I want to increase the force of impact, what should I do? An example that you see, like the airbag system. During a car crash, the airbag prevents what? The airbag prevents the driver's head from hitting the steering wheel. So the airbag comes out, and then when the impact happens, what happened? The airbag lengthen the time of the impact, right? Because the airbag it can be compressed. It is flexible. It is not very hard. It is very soft. It can be compressed. So when you hit the airbag, it can be compressed. So it's kind of lengthen the time of impact. It increases the duration of impact. So when the airbag increases the duration of impact, then the force that you experience, the driver experience, is minimized. The longer the time of impact, the smaller will be the force. So in all this application, the airbag system, okay, the crumple zone of the car, all this decreases the impact force. We will look at one example. You have seen the high jump, okay, the pole, what do we call that? In the Olympics, there's one that people use the pole to jump over the bar, which is very high. It's about like 6 meters. The pole vaulting. Yeah, I think if I'm not mistaken, that is called the pole vaulting, where it's very similar to a high jump, but they use a stick. They use a long stick, and then they jump over this bar very high, okay, which is about average height is about 6 meters. And then they land, once they jump over the bar, they land on the mattress. Okay, let's say without the mattress, what will happen? If unlucky, he lands on the ground, the impact force becomes very large. Okay, how can we explain this? You see, here, this is the bar. Let's say the athlete lands on the ground instead of the mattress. How do you use physics concept to explain the force that he's going to experience? When he lands on the ground, okay, that is pretty shocking. Okay, maybe it will cause bone fracture, or if unlucky, maybe death, right? So when he lands on the ground, the difference between the surface of the ground and the mattress, one can be compressed, one cannot be compressed. Okay, this is the ground. When he hit the ground, what happened to the velocity? The moment it hits the ground, the velocity straight away, immediately goes to zero because the ground cannot be pressed. Okay, so initially it was having certain velocity. Okay, you can calculate. Let's say up here, u is 0. It starts dropping here. What is your acceleration? Equals to 10 meter per second square. Okay, so let's say this one, you fall for 2 seconds. Okay, that is too long. Let's say 1 second. Okay, 1 second. And I want to calculate what is your velocity when you fall down here. Okay, can you calculate this? Yes. Okay, so V equals to U plus AT, right? So your U is 0 and acceleration is 10. T is 1 second here, 10 meter per second. 10 meter per second, you are moving. What is this speed here? This speed is the speed of the athlete when it has fallen 1 second, right? When it is close to the ground, but not yet hit the ground, huh? Not yet hit the ground. When it has fallen from here down to here, it is now moving at 10 meter per second. Once it hit the ground, straight away, this velocity becomes 0. So I would write initial velocity, 10. Final velocity, how much? After it hit, 0. And how long, what is the duration where this speed decreases down to 0? Is it fast or slow? In a very short duration, right? Because once it hit, instantly it becomes 0. So maybe the time of collision, okay, very, very short, 0.02. Then, okay, you calculate your impulsive force. The mass of the athlete, let's take 50 kg. Okay, let's take 50 kg, just an example. Now, then force of collision equals to mv minus mu over t equals to 50 times into final momentum, right? So 0 minus 50, initial velocity is 10 over 0.02. Okay, 0 minus 500 over 0.02. What do you get? 500 divided by 0.02, 25000. What is the unit in Newton? 25000, 25,000 Newton is acting on the person when he hit the surface at this velocity and also at this time of impact. How large is 25000 Newton? Is it large? Is it bearable? Okay, it's very easy. You just divide by 10 because Newton, you want to convert to kg, you divide by 10, right? So that is 2500 kg. Imagine I take a 2500 kg hammer, I hit you. How is it going to feel? It is not bearable. Okay, imagine you being hit by this 2500 kg hammer. Cannot bearable. So the force of impact is very large. What is causing this to be that large? The time of collision. Okay, the point here is the time of collision, because you cannot control your velocity. You cannot control your velocity. You fall this fast. But what you can control is the time of collision. How do you control the time of collision? Okay, we put a mattress. We put a mattress. So this is the mattress here. When the person hit the mattress because the mattress is flexible. It can be compressed. So here, it hit the mattress and then it go down here. Somewhere down here, only the velocity becomes 0. Before, up here, velocity 10. Okay? Where is that velocity 0? Not at the surface. The velocity 0 is when it pressed down here, somewhere below here, where it has used this amount of time as a buffer. It has lengthened, we say. It has lengthened the duration. Lengthen time of impact. For the ground, the hard surface, once you are at the surface, straight away, your velocity 0. At that instant, it cannot be pressed down. So the mattress, you can press it down. Same as if you fall into water. Here, you fall into the sea. Before hitting the sea, your velocity is 10 meters per second. When you hit the sea, does your velocity straight away go to 0? No. You sink, you go deeper and deeper, somewhere down here, your velocity is 0. So how much time you have borrowed? You have borrowed this amount of time. The time of impact has lengthened. The time for your momentum to change has lengthened. I repeat again. The time for your momentum to change has lengthened, has increased. So your force of impact become very small. Here. Okay, does it make sense? You see, force depends on what? Rate of change of momentum. The faster your momentum change, the bigger is the force. The slower your momentum change, the smaller will be the force. How do you make your momentum change slower? You increase the time of impact. People who have experienced deep emotional pain, what people say is, give it some time and then it will heal. Okay, it could be a breakup, anything. Give it some time, it will heal. Again, give it some time, lengthen the time. So the force of impact will become small. Okay, that is another meaning of it. Philosophy. Okay, just an example. All right, now you get the point. Right, so we have so far understood what? Newton's first law and Newton's second law. And then after this, we will do a little bit of exercises, practice. I will send you a few worksheets, okay, to start. Before that, you can take a 5-minute break. 5-minute break, and then we come back after 5 minutes, and we'll do the exercise. Okay, I've already sent the momentum and impulse exercise. You can start now. And then I have another one, the inertia. The unit for impulse can be kg minus 1, or it can be ns, because it has got two formula, right? So if you use the ft, it can be Newton second. So either Newton second or kg/ms minus 1, both are correct. Impulse is a vector or a scalar. Because momentum is vector, so impulse must be vector as well. Okay, this is also vector. Okay, so if an object like having momentum of 100 to the right, and let's say at the same time an impulse of 5 kgms also acting on the object, what does it mean? Impulse is the change, right? So if I say initially object having momentum of 100 to the right, and if you add an impulse of 5 to the right, then the final momentum would be, you just add the 5, because the 5 is actually the change. So you want to add it because they are the same direction. So it's like plus 100 plus 5. This, if you put a sign, right, the impulse has a positive here. So we are actually adding this one. So you have final momentum as 10, 5 kg ms minus 1. Now the same situation, but if I say that the momentum is 100 to the right, but there's an impulse acting to the left side like this. Okay, this is minus 5 kg ms minus 1. That means when you add it, you're actually minusing it, right? So the final momentum would have to the right, but 95. So just do not confuse between momentum and also impulse. Impulse is the change in the momentum, okay? And if they are the same direction, you add to it to find the final. If they are different direction, then you minus it. Right, so you try the question 1 to 4. And for question 5, I will discuss that one. Okay, you don't do question 5 first. 1 to 4 first. Okay, Adriel says C. Find the change in momentum of a body of mass 5 kg when its speed changes from 4 to 7 and its direction of motion is reversed. Okay, so that means initially it is moving at 4. Let's say we pick a direction. Let's say it's moving to the right. It doesn't really matter where is it moving, as long as the 7 is opposite to it. Okay, so initially it's moving here 4, and then the speed changes to 7. The direction of motion is reversed, right? So if it moving here, then it must be moving the other way around 7. Okay, then we calculate what is the initial momentum, mu, equals mass is 5 times 4. Okay, that's 20 kg ms minus 1. What about mv? That's the final. Now the final has the opposite motion, so 5 times minus 7. Okay, so minus 7 times 5, 35 kg ms minus 1. So once you have the mv, mu, you just put in here mv minus mu. So minus 35 minus 20. So you're actually adding them together. So it becomes minus 55 kg ms minus 1. So the change in momentum is minus 55. Okay, I want to look at question 5. Okay, maybe you can stop a while first and you look at question 5 here. I'll show you one example 5. And then 5, 6, 7, 8, 9, 10. Actually, the question, they are similar. The pattern is the same. So you want to look here. Otherwise, later you will not be able to solve 6 to 10. Okay, I'll show you how to solve this one. Okay. Water issues horizontally from a hose of cross-sectional area of 5 cm square at a speed of 10. The water hits a vertical wall without rebounding. Okay, find the magnitude of the force acting on the wall. This one, the question is asking you to find the impulsive force. It's like when the water hit the wall, right? There's the force produced due to the impact. Let me draw the diagram here. So it's better if we can visualize it. Let's say this is the hose. and it says that it is having an area of 5 cm square. Okay, so imagine that we have a hose here filled with water, okay, at the opening here. Now, and it says that the water come out at a velocity of 10 meters per second. It goes on, hit a wall without rebounding. What does it mean by this one? Without rebounding, that means we are going to consider the two situations when the water is traveling to it and when the water hit it and then stop. We do not consider what happened after that. Okay, that's why we don't look at the rebound or anything. We only consider two situations. It moving towards it, it hit it, and it stopped. That means our final velocity is going to be 0. Okay, so it hit and stopped. What is our initial velocity? U is 10. Okay, so the water come out like that. Now, we want to find impulsive force, right? So F equals to mv minus mu over t. We already have the u and the v, but how do we find the m? Because the mass of the water is not given, but you're given the density here. Okay, here's how we find the mass. We first find how much volume of water per second. Because this water is constantly flowing out. How do we get the volume if the water is constantly moving, flowing out? We cannot get, right? So we can only calculate what is the volume of water coming out every second. Okay, so imagine that with the water come out here, in 1 second it comes out. How long is the length here in 1 second? The length of the water coming out, how long here? If I take 1 second, you have the velocity 10 meters per second. That means the water come out in 1 second is come out at 10 meters. Okay, so that means this will be 10 meters in 1 second. Okay, using the velocity here given. So we can calculate how much volume coming out in 1 second. I just take whatever the volume of water here, V. Okay, so this, we have already the area. We already have the area and we got the length. So you imagine the water is like a cylinder because the hose is cylinder, right? So the water coming out, this is the amount of water coming out. We have the area of the cylinder, the cross section, and then we also have the length that it comes out, 10 meters. This is 5 cm squared. Okay, we can calculate the V. Okay, so I will call this volume of water per second. Yeah, now, okay, what is the volume? V equals to A times L. You need to convert the 5 cm squared. So 5 times 10 minus 2, you square it, you get meter. Okay, times the 10 meter. Okay, we calculate this, we get 5 times 10 minus 3 meter cube. Yeah, we have to convert this cm squared. All right, now we already have the volume of water coming out every second. Now we can get the mass as well. We get the mass of water per second. Okay, now, sorry, here, there should have S minus 1 because this is volume water per second. So m cube slash minus 1. Okay, m cube slash S, like that, per second. Okay, so same for the mass of water. Now, how do we get the mass of water per second? Is that we will use the density equals to mass per volume. So density times volume will be the mass. So I would put it here. Density is 1000 times 5 times 10 minus 3. We get 5, right? 5 kg. Don't forget this is the kg per second. So I will write kg/second. Okay, because this volume is per second, so the mass will also be per second. All right, so we get 5 kg per second. So what we have found here is every second 5 kg of water is coming up. Then we can calculate the last step using this formula. F equals to mv minus mu. I'll just put the m outside lah. mv minus u t. Mass is 5 kg and final velocity is 0 minus 10 over, what is the time? Everything is in 1 second, right? Everything is in 1 second. So mass is in 1 second, volume is in 1 second. So this is 1 second. Okay, so minus 50 Newton. That is your answer. Okay, from your calculation, you get the minus. What does the minus mean? The minus means the force is the opposite direction. But the question, you see, the question, it says, find the magnitude of the force acting on the wall. The force acting on the wall would be pointing to the right. So we will drop the negative. That means it's 50 Newton. Okay, so 50 Newton, that is your answer. This is for question 5. The principle behind it is the same. Momentum and impulsive force. But the question, okay, is a bit different. This is moving water. Okay, the moving water jet. It's like the water jet, the force produced by the water jet. You have seen like machine that they send water at very high pressure, exit the nozzle, right? And then the high pressure jet of water can cut through all the materials, right? So that is also has to do with this one, the pressure or the force from the water jet. Okay, question number 5, number 6, number 7, 8, 9, 10, they are very similar. You try 6 to 10. If you have any questions, you need more clarification, you feel like you still don't get it, okay, you can let me know in the chat or in WhatsApp.